Okay, guys, in this lesson, we're going to talk about the real numbers. We're going to talk about the difference between what is a rational number and an irrational number. Here are the sets of real numbers, and let's start with the innermost set that you learned when you were first counting. These are the counting numbers. They're the things you can count. Then we added in the number 0 and created the whole number set. Then we included the negatives of the whole numbers to create the integer set. And then we have the rational numbers, which includes all the integers and all the numbers in between the integers. Over to the right, we have the irrational numbers, which are those numbers that cannot be written as a ratio. But both the rational and irrational numbers are both sets of the real number system. So let's talk specifically about rational numbers. A rational number is one that can be expressed as a fraction or a ratio. And you can see the word ratio inside the word rational. So if you can write a number as a fraction, then it's considered a rational number. When we have a rational number fraction and it's divided, we will get a decimal that's either terminating, which means it comes to an end, such as 8.2, or it's a repeating number, such as 8.2 repeating. Here are some examples of rational numbers. -1/2, it is written as a fraction. 6 and 25/100ths, we can write that as a fraction. The square root of 4, which is really 2, and then we can put it over 1 to make it a fraction. 8 can be written as 8/1. 7 and 1/2 is written as a fraction. And then a repeating decimal, 0.45 repeating, we can put it over 99. And we'll learn about this later in this lesson. So all these numbers can be written as a ratio, therefore they are rational numbers. Irrational numbers are those numbers that cannot be written as a fraction. When an irrational number is expressed as a decimal, it goes on forever and never repeats. So here are 3 different examples. Let's start with a basic irrational number, where this number is a decimal. It goes on forever and it does not repeat. It never ends. We don't know what place value it would end up in because it continues, therefore we cannot write it as a ratio. If we put the square root of 3, which is not a perfect square, in the calculator, we would end up with a number that goes on forever and doesn't repeat. And then pi we say is 3.14, but it's really just approximately 3.14. It goes on and on and on without repeating. So the 2 descriptors for an irrational number is a non-perfect square, such as the square root of 3, and those that are non-repeating and non-terminating decimals, such as the example above. Here is a summary of a rational number and irrational. So if you need to pause the video, please do so and write these in your notes. Now let's take a look at these examples and classify them as rational or irrational. Let's start out with the square root of 12. It's not a perfect square. If we put it in the calculator, it would be a decimal that goes on forever without repeating. -3, that is rational. Pi is irrational. 2.173 is a terminating decimal. It comes to an end. We could write it as a fraction. -3.276 ... that goes on forever without repeating. It is irrational. The square root of 49 is really 7, so it is rational. The negative square root of 196 is a perfect square, so it is also rational. -2 times pi is irrational. The square root of 400 is a perfect square number, so it's rational. 5.12 repeating. Any repeating numbers, repeating starts with R, rational starts with R. Any repeating decimal is rational. -2/3, it's showing itself that it is a ratio. 4.12, that is a terminating decimal. 4.5, repeating, rational. The square root of 1 over 9, it looks like it may be irrational, but if we simplify this, we really get 1 over 3. They're both perfect numbers, 1 and 9. So this is a rational number. 3/7 is rational. 7.1345 ... is irrational. Negative root 3 is irrational. 2 times the square root of 3 is irrational. Now pi over pi cancels and gives us 1, so this expression really is rational. And then 21 is rational. Now let's take a look at how we convert repeating decimals into fractions. And I'm just going to show you the shortcut. I'm not going to show you the algebraic way. So this is just a shortcut. So 2.3 repeating. First of all, we have our whole number. Then we have one digit that is repeating. So you take that number and you place it over a single 9. 2 and 3 ninths. Of course, 3 ninths can simplify. Now let's take a look at 4.09 repeating. We have two digits, 09, 09, 09. So we have our whole number, and then we have 09, or just 9. And since it was two digits, we're going to have two 99s. So 99, or I should say 2 nines, which is 99. Of course, we can simplify that as well. In our last example, we have 0.267, 267, 267. So we have 3 numbers that are repeating, so we're going to have 3 9s. And that's just the shortcut of how to write a repeating decimal is a fraction to show it is a rational number. Okay, the last thing we're going to go over is there are certain outcomes when you add or multiply rationals together, irrational, or a combination. So let's go through and give an example that when we add two rational numbers, we're going to get a rational. So that's easy. Just 5 plus 2 gives us 7. So we have a rational plus a rational produces a rational number. Now let's do multiply two rationals and you will get a rational number. So we could say 1/2 times 1/3 and we get 1/6. Again, a true statement. Now, what about when we have an irrational plus an irrational? We're going to get an irrational number. So let's just take the square root of 2 plus the square root of 2. So we have 1 square root of 2 plus another square root of 2. So we have 2 square root of 2. So you see we get an irrational. How about when we multiply an irrational times irrational and get a rational number? So let's just take this same square root of 2 times the square root of 2. Both of these are irrational, but we get a perfect square, which is a rational number. Okay, how about irrational times irrational and get an irrational? So let's say the square root of 2 times the square root of 3. Both of those are irrational. We get the square root of 6. So you can see here that when you multiply two irrationals, sometimes you'll get rational and sometimes you'll get irrational. Now we have a rational plus irrational and we want to get irrational. So let's go with 0. That's rational plus the square root of 2. That is irrational. And when we add those together, we get an irrational number. Now we have rational times irrational and we want to get a rational number. So let's think of, we could say 0 times the square root of 2. We have a rational times irrational. That would give us a rational number. And then the last one, when we multiply, let's say we have a rational. So let's say 2 times the square root of 2 gives us 2 times the square root of 2. So we can see that these two sets can produce rational or irrational. And then we can see, whoops, didn't need that bracket. It's this last set right here. So when you have multiplication of rational and irrational, you can either get a rational outcome or irrational. So this set and this set is sometimes true. So sometimes rational times irrational is rational, but sometimes I get irrational. On these other ones, these are always. So when you add two rationals, you will always get a rational and so forth. And let's erase this, make this a little bit neater here. Perfect.